This is going to be the start of our waves unit. And wave basics, the definition of a wave is going to be the transfer of energy by vibration of a medium. Now the word medium is the material the wave travels through. Okay, so a water wave is traveling through water, that's the medium. Now, types of waves. First one we're going to talk about is called a transverse wave. And in a transverse wave, the medium vibrates perpendicular to the direction of energy transfer. So it's going to look something like this. Okay, you're going to have a wave that looks like this. All right, the energy is going this way. But if I look at any point on the medium, it's just vibrating up and down. And most waves look like this. We can think of examples of this, the water waves, waves in a stream. Or it turns out that light waves are also this type. The second type is longitudinal. It's a little hard to draw it or visualize it, but it's going to look something like this. Okay. What's happening is, as the energy goes this way, okay, the pieces of medium vibrate back and forth. Now, as they vibrate back and forth, you're going to get areas where it's compressed and areas where it's spread out. It's called a rarefaction. And an example of this is sound waves. Like I said, that one's kind of hard to visualize, so I found a little plot that will show that. So that is right here. Okay, we're going to start with a transverse wave, which is something that you're probably pretty familiar with. So if I just hit play here, you can see that the wave is traveling to the right, and the particles are just moving up and down. So they marked one in red here, okay? And that one that they've marked in red is just moving straight up and down as the energy moves along to the right. Now if I click on longitudinal, it's going to show that, okay? And for this one, as the energy is being pushed over to the right, this red line is just moving back and forth. So that's a longitudinal wave. Now, there's some things we can measure on a wave. We're going to call wave properties. And a cycle is one of a series of repeated sequences. It's basically from one point until it starts to repeat. So an example of that would be, say, from here I go up and down, come back up again, and that's where it starts to repeat. So I'll wiggle at A, B. So A to B would be one cycle. Now we don't have to start there. We can start at the top here. C to D is one cycle. Or I can start anywhere on the wave. I can start here, and then I would have to go all the way over here where I'm repeating. It's not here, okay, because even though it's the same height, it's kind of going in the opposite direction. So I have to go from E to F for a complete cycle. Now the wavelength, and the letter for wavelength is a Greek letter lambda. It looks kind of like an upside down Y. Okay? And this is the distance for one cycle. And the unit is going to be meters. So if I take a look at this one, from here to here, it's 6 meters. How many cycles is that? One cycle, 2 cycles, 3 cycles. So for the example we're given, we have 3 cycles. It's 6 meters. Well, how much is each cycle? Each cycle would be 2 meters. So the wavelength is 2 meters. So from there to there is 2 meters. Now the frequency is how frequently the wave repeats. Okay, that's the way I think of it, how frequently it repeats. And it's going to be how many times, how many cycles in 1 second. So frequency in cycles per second. That's a little different than they define it in math class. In math class, they say cycles are 2 pi, but in here it's cycles per second. So for this particular example, again, if I look at this point to this point, it was 3 cycles, and that was in 5 seconds. So for this one, it would be 3 cycles over 5 seconds. That would be 0.6 cycles per second. Now, that's also called a hertz. So the unit frequency can be hertz. On the next page, we start talking about period. Period is the time for 1 cycle. So basically, this is going to be seconds over cycles. Right? You'll notice that that's kind of flipped over for what frequency is. So one way to find period, and the letter for period we're going to use is capital T. It's going to be the reciprocal of the frequency. So for the example we had, if you remember, we had 3 cycles was 5 seconds. So if I'm going to use seconds per cycle, I'm going to say the period is equal to 5 seconds over 3 cycles is going to give me 1.6 repeating seconds for the period. The other way you could have done it would have been 1 over f. And if you do that, the frequency is 0.6, whatever 0.6 is 1.6 repeating. Well, that thing is the amplitude. The definition for this is the maximum displacement from equilibrium. Now, the easy way to think of it, at least in a transverse wave, is the height. So if I go back and take a look at our wave, here, okay, it was 3 meters from the top to the bottom. The equilibrium is right here. So it'd be 1.5 meters here, and that's going to be the amplitude. So we're going to say, for our example, the amplitude is equal to 1.5 meters. Now we're going to get to velocity in the next video.